Hello, everyone, and welcome to The Vertical Space, a podcast at the intersection of technology and flight. We are your hosts, Jim Barry, Peter Shannon, and Luka Tomjanovic, and here we look at the most important forces shaping the market of advanced air mobility with a particular focus on why and how they matter to those building a business in this very exciting and growing industry.
When people talk about autonomy, I get the sense that people are imagining some kind of Skynet, a all-knowing, all-seeing AI that takes off from some uncontrolled area and might land in your backyard and pick you up and decide where to take you. And in reality, what we're talking about is something that is a lot more like a gondola. It's a tram in the sky, to mix some metaphors there. It takes off at one very precisely controlled location. It travels a very precisely controlled route, and it lands at another very precisely controlled location. And at any instance in the middle, there's always a safe place for the aircraft to land under any known contingency. So one of the most important things to understand is that there's a large spectrum of what that term can mean. But the most important thing to just bound why this is sooner than later is to understand that we're talking about extremely controlled scenarios using very high levels of integrity and assurance in the underlying systems to be able to close a safety case in something that makes sense in today's air transportation system.
Welcome back to The Vertical Space. Our guest today is Brian Yutko, Chief Executive Officer at Wisk, a California-based advanced air mobility company developing a fully autonomous electric vertical takeoff and landing air taxi. Demystifying autonomy is a fitting title for the insightful and fascinating conversation we had with Brian. He thoughtfully argues that autonomous electric flight for small aircraft, the likes of Wisk's eVTOL, will become a commercial reality much sooner than most people think, only a few years from now. Of course, when making such a bold statement that most would push back on, definitions and details matter. And in the case of Wisk, the concept of operations involves flying on an IFR flight plan in extremely controlled scenarios using very high levels of integrity and assurance in the underlying systems, both on board and on the ground. Listen to Brian explain the state of technology, as well as the systems engineering and product development standing in the way of this ambitious goal. We also discussed a few myths and misconceptions that exist in the industry, namely that the value of autonomy is in eliminating pilot cost, or that the future is either piloted or autonomous. This has been such an insights-packed conversation that it's tough to summarize it. If you're interested in autonomous flight, the systems architecture that will support it, certification pathways for autonomous flight, sustainable flight, or just what it's like to build a business in advanced air mobility, you don't want to miss this episode. As Chief Executive Officer, Brian is responsible for the strategic direction of Wisk and oversees all aspects of the company. Brian brings years of leadership and engineering experience in aerospace and aviation, with a particular focus on electric and autonomous aviation. Prior to joining Wisk, Brian served as Vice President and Chief Engineer for Sustainability and Future Mobility at Boeing, where he led a team that ensured the company's technical expertise and market leadership in sustainability technologies, as well as emerging advanced aerial mobility applications. He has held numerous additional leadership roles, including Chief Technologist for Boeing Next and Senior Vice President of Programs at Aurora Flight Sciences, among others. Brian earned a PhD and a Master of Science in Aeronautics and Astronautics from MIT and a Bachelor of Science in Aerospace Engineering from Pennsylvania State University. Thank you very much, Brian, for being on The Vertical Space. This episode of the Vertical Space podcast is brought to you by UAvionics. UAvionics is the leader in low size, weight, and power certified avionics for manned, unmanned, and advanced air mobility aircraft. Let UAvionics help you achieve your goals, whether that be type certification, airspace access, or beyond visual line of sight operations. UAvionics has certified and certifiable communications, navigation, and surveillance avionics for your aircraft. So head over to uavionics.com or Google it to see how you can start flying safer and move your platform forward into shared airspace.
Hey, Brian, welcome to the Vertical Space. Great having you on.
Great to be here.
So first question, is there anything that very few in the industry agree with you on?
Lots. I think the thing we'll talk the most about on this podcast is My sense is that people think passenger carrying autonomous aircraft are often some far distant future that we can't even imagine. But in reality, I think they're actually ready now, and the certification pathways to get them into service exist now. So I'm sure we'll spend a lot of time talking on that. But I love this question, so I'll throw out a few other things just for the fun of it, which is my sense is also that people in the innovation community, people like me, tend to actually look down on the traditional air transportation system for its lack of innovation, I suppose. And one of the things that just strikes me every time I travel is I am just simply astounded every time I go to the airport and I can incredibly safely fly between some origin and far-flung destination at a very low price and use the internet on board. And I could do it at 80% lower emissions, than we could have decades ago. I just think commercial airplanes are modern miracles, and I don't think they get enough credit for it. And maybe the last thing I'd mention is I really don't like the terminology UAM and RAM and some of the other acronyms that we use. I think they're confusing. But anyway, I'll stop there. I love this subject. I have some non-consensus views on a number of topics.
So, Brian, even based on what you just said, which is great, and what people don't agree with you on, I think a lot of people listening right now will probably challenge you on the autonomous operations and that it's just a couple of years away. Now, I think it's nirvana, right? I think it's the ideal. So what would you say to them? Let's just get right into it. What would you say to them, to, let's say, investors who say, boy, I think you're talking 10 to 20 years away? What would you say to them?
I'd say we have to define what it is that we're actually talking about. And if we carefully define what it is that we're talking about, I think they would have an understanding that it's much sooner than they might think. And so just to parse that and try to make it make sense. When people talk about autonomy, I get the sense that people are imagining some kind of Skynet, an all-knowing, all-seeing AI that takes off from some uncontrolled area and might land in your backyard and pick you up and decide where to take you. And in reality, what we're talking about is something that is a lot more like a gondola. It's a tram in the sky, to mix some metaphors there. It takes off at one very precisely controlled location. It travels a very precisely controlled route, and it lands at another very precisely controlled location. And at any instance in the middle, there's always a safe place for the aircraft to land under any known contingency. So one of the most important things to understand is that there's a large spectrum of what that term can mean. And we can get into some of the specific functions about how to define it, because I think it's important to think functionally on this. But the most important thing to just bound why this is sooner than later is to understand that we're talking about extremely controlled scenarios using very high levels of integrity and assurance in the underlying systems to be able to close a safety case in something that makes sense in today's air transportation system.
And Brian, when you say extremely controlled environments end to end, how much of human involvement do you have in mind?
Yeah, so the first thing to kind of point out on this is we have an incredibly detailed concept of operations where we have publicly released exactly how we imagine services like this working. And it actually introduces who are the actors that may be participating in the system, what are the names of these new actors, and so on and so forth. So to give you a sense, we have established what we call a multi-vehicle supervisor. So a human on the ground, which would oversee the operations of multiple aircraft. That's the intention of that supervisor. Now, when we walk people through our lab, where we have our supervisor stations, which are being developed right now, the first question is usually, where's the joystick? And there is no joystick. The supervisor does not control the aircraft in the way that you might imagine with an inceptor to be able to fly it in any which direction. What the supervisor does is actually provide a complementary service. It does what humans are great at, which is, a higher level judgment and some very specific decision making, which I can get into. But in large part, the system is fully automated and fully responsible for its safety on that very narrow, structured, specific operational environment. So as an example, the way that I like to think about it is when the aircraft takes off, the aircraft is fully capable and in fact fully responsible for safely getting itself back on the ground without any human supervision. The on-the-ground supervisor would provide some collaborative activities, so things like talking to air traffic control to receive voice vectors, things that are required on today's IFR routing, as an example, and can provide those to the aircraft. But the supervisor is not sitting there looking at gauges and assessing the state of the system to understand if the aircraft is okay. The aircraft does that for itself.
Look forward to digging into some of these aspects in more detail. But first of all, describe what was your day one at Wisk. How was it different than what you thought it would be when you left Boeing?
Of course, yeah. In some ways, 0% different than what I thought. And in some ways, a lot different from what I thought. And I could get into that. In some ways, it was a bit of a homecoming for me in terms of returning to a small company that is really doing something incredibly innovative, with the team of hundreds of engineers. It's very similar to some of the experiences that I had at places like Aurora Flight Sciences. Boeing obviously has tremendous scale and product excellence. And so in many ways, what I view Wisk as is a blend of those two experiences to do something that really kind of pushes the frontier, but does it with, a product mindset. And so in that respect, it's, everything that I thought it would be. In some senses, the things that were different were, I was actually pleasantly surprised with the extensiveness of and the comprehensiveness with which the team here was tackling this problem. I think you could look at a company like Wisk and assume that we've flown a number of generations of uncrewed aircraft. And so therefore, we just think that we could put a person on board and it'll be good to go. But really what's going on here is some of the most comprehensive systems engineering, functional decomposition of a commercial autonomous system that I've ever seen. And so, as I got in and started pulling back the layers of kind of operational details, things that you don't get to see when you sit on a board of directors, the operations of the company, I have been pleasantly surprised at almost every turn. And it goes without saying that the team that does that work is just outstanding.
And Brian, once you saw let's say the financial projections on the board, you clearly understood what the vision would be. But once you became the CEO, which projections you felt better about? Which ones were you more concerned about and why?
Well, I don't know if I would say better or worse, but what I would say is I'm really interested in understanding scenarios. And I think that we may have a hesitancy just as an industry to try to boil everything down into one forecast. And I think there are so many unknowns in front of this industry, not just Wisk, that I have a hard time anchoring myself to any one particular forecast. I like to think about what would you have to believe in order to achieve an economics of X, Y, and Z, or an operational environment of A, B, and C. And so, what I've really been focused on since I've come in here is trying to introduce some more scenario thinking, which the team has done very effectively. And I really appreciate that because it starts to also illuminate what are the things that we have to really focus on in order to achieve the more interesting scenarios.
What was the most uncomfortable question that you received since becoming CEO, whether this was from employees or partners or investors or just broadly the industry?
Uncomfortable question. That's interesting. Well, I get the sense that, obviously my prior job was at Boeing, and this is a small company. And so, of course, people would ask me, are you going to turn this small company into a larger company with the way that it operates and so on and so forth? And of course, I don't have any intention to do that. And I have a deep background in operating small companies. So I think there was a bit of folks always look at what was your prior job and say, how will what I think about that organization affect this organization? And so, we just sort of address that head on and ask people to give me a chance and to see how things go. And I think the team here is really excited about the work that we're doing.
All right, so how about we jump back into the product and tech discussion? Can you tell us a little bit about, or a lot, what critical technologies are necessary to safely achieve this high tempo of autonomous operations as you defined them earlier? How long will it take? Where are we in the maturation of these technologies?
Yeah, well, I think it's worthwhile to kind of parse that a little bit further and say technologies and then development. And what I mean is the technologies we believe exist. Now, they can always be improved, and I'll give a few examples. But what we're really facing into is a substantial product development activity, which is to take technologies that are mature and conceive of them in a system that has a very high level of design assurance in certain areas and maturity, and get it ultimately through testing and validation. So what we need to do is to make an aircraft system that is fully responsible for many of the operator functions, which would normally be the responsibility of a pilot, and not merely assistive of them. So an example would be deconflicting from traffic and terrain hazards, precision landing and GPS denied navigation, and things of this sort. That naturally turns into, a technology discussion about things like sensors with high design assurance levels, or what are the human factors for the design of the supervisor stations on the ground, and so on and so forth. We can get into some of those. But I think that the important thing to recognize is that we think that the technologies that are required in order to get to market and to carry the first commercial passenger on an uncrewed aircraft, those technologies exist. And now the challenge is doing the very, very difficult systems engineering and then getting those systems into an architecture where you can prove that they're safe enough such that we can meet an equivalent level of safety to what passengers would experience in today's air transportation system.
So how would that work? For instance, let's just pick one of those functions like detect and avoid. Can you dissect this problem as you see it? What's the state of technology that exists out there? And to what extent do you and your partners tweak that into a high design assurance level product that can actually replace the function of the pilot, as you said, and not just serve as an assistance?
Right. So how this works today, it's important to think about, how does the full airspace deconfliction chain work today? So today, separation services are provided by air traffic control, and then they're complemented by a pilot's ability to see and avoid as the last layer of deconfliction. And, somewhat famously, the see and avoid or detect and avoid problem is maybe one of the most vexing in our industry. Our approach is to break that down, again, just with good systems engineering. The most simple way to think about the breakdown, just for the purposes of this conversation, is detect and avoid is two functions. It's detecting and it's avoiding. And so if you think about let's start with avoidance just as an example. So avoidance, we obviously, we would be talking with our supervisor to air traffic control. So there's no scenario in which we're not speaking with air traffic control to provide normal separation services, take vectors, file IFR flight plans, receive approvals for those flight plans, et cetera. So we would always be on IFR flight plans. Obviously, in initial operations, there's no scenario under which we're a VFR operating aircraft because there is no visual person on board to be able to provide and comply with visual flight rules. So we would be on IFR flight plans, and we would be speaking with air traffic control to take things like vectors and so on. Now, obviously, we would need algorithms on board the aircraft in order to remain well clear to do things like some strategic level of deconfliction. So imagine speeding up or slowing down to avoid a conflict in the first place. And those algorithms we make. There are also commercially available algorithms like ACAS XR and the ACAS family of algorithms, which the FAA and places like MIT Lincoln Labs have pioneered. And those are available to us. And we will use those for a last layer of automated deconfliction. And so that's how the avoidance function works. And it can break down, sort of ever further from there. Detection, and this is one where it's really important to understand the operating environment that we intend to operate in. I think there's a little bit of a notion that doing this in in a high use airspace. So things like near class Bravo in an urban area, as an example, will be more difficult. But it turns out, well, I should say more difficult than a rural environment. But it turns out that we actually benefit from the highly structured nature of those kinds of environments. So autonomy benefits from structure. It becomes a more difficult problem in very rural environments where you lack structure. What I mean is, for detection, as an example, the mode C veil around most major metropolitan areas is helpful because it means that most aircraft, in fact, the vast majority of aircraft will have transponders. They'll have ADS-B. The vast majority of aircraft in those environments will be quote unquote cooperating and will be on well-defined IFR routes, will be on IFR flight plans. Additionally, we'll be working with third-party partners, ideally, ultimately what the FAA calls PSUs, I'm sure we'll get into that, to obtain surveillance data to augment with ground-based sources to bolster our traffic picture. And as a last line of defense, and only as a last line of defense, we'll be carrying additional active sensing technologies on board the aircraft. And those would be things like radars or potentially optical sensing or potentially other spectrum that we would fuse together to be able, in an active sense, to provide a view around the aircraft. So I think it's important to kind of just think about that both in those, just as a functional thinking to imagine how you start to break down this problem and how you take the right technology tool for the right job in the right operational environment.
Brian, could you kind of chart a path for our listeners, let's say from takeoff to landing? Let's say your first profitable route. Where would it be? And what technologies, pre-departure and takeoff, en route and landing, what technologies exist today that are not a concern for you? On your whiteboard, it's not a risk. And then what technologies are deployed at each element of the flight that you absolutely have to have? And then what's the timeline for development for those technologies? But just try to keep it simple for our listeners to understand, it could be, after your explanation, they say, this is a lot sooner than I would have thought. And it sounds like they've thought it through. And then these are the risks that they're most concerned about, but they have a clear idea as to how they're going to address those risks.
Yeah, maybe to simplify, this would be, so you mentioned just earliest routes, the initial kind of entry into operations, how we expect this to work. This would be exactly the same as flying an IFR flight plan, exactly the same as flying, imagine a helicopter route as an example. We can get into the FAA ConOps where they specified corridors very specifically, and we could talk about that. But just to keep it simple, imagine an aircraft flying an IFR route. It will file for a clearance for that route. So it will be able to take off at its origin. It will have well-defined waypoints along the way, and it will land at its destination. And all of that will be automated in the exact same way that we automate flights today and have, let's say, Cat 3 type landings always, because there's no one on board to actually provide the visual determination of the conditions at the airport. So that's maybe the simplest way to understand this is it is literally flying an IFR flight plan. Now, to go one layer below that, maybe, what technologies enable that? Well, very high assurance navigation systems. So things like an INS or multiple potentially, which provide sensing on board the aircraft to understand, which way is up and which way is down and which way we're going. And that is a very, very mature technology at this point. So the inertial navigation systems for these kinds of aircraft are extremely mature. And what we're doing is putting those in an architecture that's commercially certifiable. The things that are maybe a bit more critical for this application, which we'll push the boundaries on a bit, will be things like how you navigate when you can't count on GPS. So as an example, we will want to be able to localize where we are above the ground or in relation to a landing site. And there's tremendous precedence for how to do this. So as an example, on your commercial airplane flight, you may use an instrument landing system, an ILS, in order for the pilot to be able to navigate to the airport environment and ultimately to the runway when the pilot can't actually see the airport environment or the runway in exactly the same that our automated system would be tasked with doing. So just to kind of recap that, is the simplest way to think about this is an aircraft on an IFR flight plan. And what we need to do is to be able to add additional assurance and redundancy to how that flight plan is actually executed. But those technologies exist. And the only thing that they require is someone to extremely comprehensively tackle the problem, which is what we're doing.
And in this model that you described, will air traffic controllers have the same freedom and ease to redirect the aircraft as needed, or will they be needing to treat it differently?
We expect, especially initially, that the air traffic controllers would have the exact same freedom to be able to provide vectors to the aircraft, as an example. Now, there would, of course, be scenarios where we may receive a vector or stay on a vector for so long that the automated system would determine that it's entering an unsafe condition, an unsafe state. And so in that scenario, the aircraft would return to its intended landing site in the same way that a pilot who was running out of fuel would deviate and would land safely.
And would they do that via voice over VHF, just like they do with all the other air traffic?
Correct. We don't imagine having any sort of voice to data environments. We will have VHF relays, and our supervisors on the ground will be speaking with air traffic control. One of the very few actions that a multi-vehicle supervisor can take, a command they can give to the aircraft, is to provide a vector.
How has the conversation gone with that part of FAA and with the air traffic control community as they give feedback and input to help build this architecture?
Yeah, so broadly, the conversations with the FAA have gone very well. I think about what we need to do in kind of three different domains, maybe three pillars. This is just my personal framework. It's not exactly how the certifications line up, but obviously we need a type certification and a production certificate, an associated production certificate. And we think that the existing processes to get to that are sort of well-worn or becoming well-worn at this point. And they're cumbersome and they're rigorous and they're all the things that they should be. And, they could be more efficient and all the things that you may hear from folks in this industry. And that's okay because, they ultimately exist and they're rigorous and we're leaning into those and we're executing that part of the program. So that's the first pillar. The second pillar are operational approvals. So obviously, we're talking about doing something that is slightly different from what is done today. And if you take my example of, IFR flight plans, I say slightly different because that's the point. We're not trying to say these aircraft can fly anywhere whenever they want. We think that is an incredibly hard problem. And so we're trying to operationally simplify as much as possible to be able to start to deliver this autonomous service. And so we will need waivers and exemptions in the current processes to be able to accomplish those operational approvals. And then the third pillar, so that's the second pillar. And the third pillar are the qualifications that are required ultimately for the supervisor that sits at the supervisor station and provides complementary functions for interacting with the aircraft and interacting with air traffic control and other entities in the system.
ATC vectoring aircraft, how that impacts the idea of a very highly precisely determined nature of the routes. How far do you need to stretch this concept before the aircraft, as you say, needs to return back to land? And in what way does it do that? So how do you think about this real life implications of flying in very congested, dense airspace environments where vectoring is a very usual occurrence?
Vectoring is an extremely typical service that's provided to airspace users in congested environments like Bravo airspace in localities around the country. However, the purpose of vectoring is primarily for spacing for aircraft that are coming in from a number of different waypoints around those terminal environments. And there are, of course, other purposes of vectoring, but primarily I point that out to say, if you look at the concept of operations that we're talking about here, we are talking about an incredibly fixed operating environment, which would be strategically deconflicted in its design from the local airspace in important ways. So that is to say, when we stand up these routes, we intend to do tremendous amounts of research to ensure that vectoring would be a very uncommon occurrence. If you look at the ConOps that the FAA just released, they developed this notion of corridors. And we don't rely on corridors. I want to be clear on that. We like the concept of corridors. We don't require them. But the notion of a corridor is, of course, that you would have some portion of an airspace that is well designed, out of the way, at an altitude that wouldn't commonly conflict with approaching traffic and require a vector and so on. And so ultimately, we think that over time, vectoring would become a very uncommon occurrence. But as we go to market, that will be one of the things that we do most closely in designing these routes, is ensuring that they are deconflicted in their design, but of course that we can take a vector if we require it.
I like the focus from the get-go on IFR operations, not only because it really helps with autonomous operations, but also because it ensures availability of the service in all kinds of weather conditions, or most kinds of weather conditions. But talk to us a little bit more. What are the implications of operating in instrument meteorological conditions, what it means to the systems on board, the energy that you need to carry additionally, the impact on range? What other considerations and implications come with this assumption? This can be the need to have instrument approaches on every point that you take off and land from, which limits the places where you can land, et cetera, et cetera. There's a lot of domino effects. Unpack this a little bit for us, please.
Yeah, somewhat counterintuitively, the notion of always flying on IFR flight rules is actually very helpful, because it starts to structure the problem in really important ways. And very literally, you of course do not have a visual set of eyes on board to be able to comply with visual flight rules. So there is no scenario in which the aircraft, even on a blue sky sunny day, is flying under visual flight rules. It's always on an IFR flight plan. And so flying in IMC in instrument meteorological conditions has very little impact. We've designed the aircraft such that it can fly in clouds and in very high winds, actually. And the only thing that we would limit the aircraft from an IMC standpoint is actually known icing conditions. We're not designing the aircraft to be able to fly in known icing initially. From an approach and landing standpoint, of course, we will benefit very significantly from GPS as part of the navigation system on the aircraft, but don't rely on it exclusively. We have high performance inertial navigation systems on board. We also have systems that are a lot like an instrument landing system that provide localization to the vertiport environment. So that is to say, we have sensors on board the aircraft, and we will have considerations at the vertiport for ultimately how the aircraft knows where it is in relation to its landing environment, in the exact same way that aircraft today that are landing on, let's say, a Cat 3 approach at an airport know how ultimately to get to the ground without any pilot input.
So you envision designing your own approach procedures?
Essentially, yes. I mean, at a very high level, an automated aircraft has to know how to get to the ground. Right now, we do that with a very robust and reliable algorithm for how to get the aircraft from a hover state down onto the vertiport. And so, rather than thinking about this in the same way that you might imagine, an approach to a vertiport that, is many, many miles away at a 3-degree glide slope or some other such thing, we could do pretty unique things with a VTOL aircraft. And they rely on very simple localization techniques between the aircraft and the vertiport.
Mm-hmm. Let's come back quickly to detect and avoid, because even if you're flying on an IFR flight plan, if the weather conditions permit, there's still the requirement or the responsibility to see and avoid in traditional aviation. So can you tell us a little bit about active and passive sensing technology that you are considering? And just broadly, where is the industry maturity along those products?
I think broadly, I'll start with the broadly part first, which is I think that having sensing solutions which are at fairly high design assurance levels and low size, weight, and power, low swap, that's kind of if you could push on any one direction, you'd always like to push in that direction, which is to say, I'd always like to have a sensor that's smaller, can see further for less power, and can do so in a very highly assured way. So I think that will be a trend in aircraft automation for a very long time to come, is pushing in those directions. So we'd always like more of that. Now, to get back to our kind of sensing solution, obviously, we will take great advantage of cooperative sensing, ADS-B transponders, et cetera. We will take advantage, not for ultimate safety credit, but ultimately for efficiency from surveillance data, from ground-based surveillance data. And as a last line of defense, we'll have active sensing. So things like radar, things like optical sensing solutions, which we haven't announced exactly what our specific architecture is. But you can imagine wanting either, very well-performing single sensing types or dissimilar sensing types that are fused together. And so those are the systems that we fly today, actually, on a number of surrogates that we have. I think it's important to note that we don't actually rely on our Gen 6 airplane showing up in order for us to advance and mature those systems. We fly today a number of helicopters that we own with sensing packages on them. One of the ways we can collaborate with people like Boeing is Boeing has a fully autonomous Caravan that we can hang sensors on and to be able to do sensor testing along with Boeing. We work with companies like Aurora Flight Sciences, which I, of course, came from in the past as well, who has an automated DA-42 that we can do sensor testing on, also a couple automated helicopters. So we have an incredible fleet of what we call surrogates to be able to do this kind of testing well before the aircraft actually shows up. And that, of course, leaves aside even virtual simulation, which we use to a tremendous extent.
What are the regulatory requirements when it comes to detecting an aircraft?
Right now, well, great question. Right now, the regulatory requirements are, as a last line of defense, to see and avoid other traffic. Of course, RTCA has done some pioneering work through the 228 committee on the minimum operational performance standards, the MOPS, for relatively high altitude, faster moving aircraft to be able to provide that capability at the requirements for ultimately what would meet an equivalent level of safety. We have a perspective on what those requirements should be, and we're working those as part of our certification program. Ultimately, I think that when you look at how we've architected the system, we will vastly outperform what a human pilot can do from an ability to see and avoid other aircraft.
So is there no clear-cut requirement? For instance, you need to be able to detect X% of the traffic at Y nautical miles out.
The minimum operational performance standards does specify requirements that can be used as part of a certification program. But right now, the regulations state, again, the requirement to see and avoid other traffic, but don't do so in such a prescriptive way to be able to design a sensing system with the requirements of the type that you're speaking about. So we can use things like the MOPS as guidance in a certification program. And so that's what we're doing.
When you scan the state of the industry when it comes to detection, what technologies are you really excited about? And whether this is camera-based or radar-based or acoustic or perhaps some other passive means of detecting non-cooperative traffic, what are you excited about and what's the state of maturity of those?
I think low swap radars are actually very exciting. It's an obvious solution, has been used in aviation for decades, obviously in a number of ways in the commercial environment, but most notably in the defense environment. There are challenges with radar, especially at low altitudes with ground returns and so on, but there are techniques to deal with that. I think optical sensing is coming along. Obviously there are challenges related to certain atmospheric environments with certain spectrum. And so those have limitations and very likely will always be used in combination, in my opinion, with other sensing types kind of fused together. The acoustic solutions, I've seen the really amazing work that Keller and the team at Zipline have done on some of the acoustic non-cooperative detection that works for certain physics, which is to say, certain speeds and so on. I don't think that that's necessarily a solution for us. But I think it's really interesting if you think of the spectrum of automated applications and smaller aircraft and potentially slower moving aircraft, that those are really neat. So I think that these kinds of things will continue to come along, and we'll be able to take advantage of many of the different sensing types that appear.
Brian, we've had a fair amount of guests on the podcast who've talked about the promise of autonomy, but they've been very concerned about those few times when you need the human who's operating the vehicle under certain conditions. And Sully, for example, has been talked about where you're not going to see autonomy for a long time because no machine could figure out what Sully had to do given what was in front of him. As a result, there's some very substantial people who think that regardless of the technologies, most of what you're talking about is under perfect conditions. But in those few situations when, somebody has to think through the scenario in front of them, there's no way that autonomy could exist for the next 5-10 years plus. What do you say to that?
Well, to be clear, our system is designed with very difficult edge cases in mind. In fact, that's entirely the point of virtual simulation, which we haven't talked much about yet. And it's also the point of very operationally limiting the aircraft to very precise routes with known pre-planned contingency landing areas and other structure that you simply don't have in today's air transportation system, the way that it's operated. So we're talking about a level of structure here in the operational environment, which is pretty substantial. But when it comes to actually designing the aircraft, the things that we care are actually not about the nominal case. Because as I explained, the nominal case is you file an IFR flight plan and you fly it. And that's actually quite easy to do. What we care about are multiple motors that have had failures. The aircraft is at an energy state which is not ideal. The aircraft needs to execute a contingency, which is to say, land somewhere else at one of the pre-planned emergency landing sites, and so on. And so those are the actual bounding cases for designing the aircraft. And we're not oblivious to those. In fact, that's actually where we spend all of our time working on the design. That's actually where most of the interesting innovation lies in how you conceive of a system like this. The thing that I would say also to kind of make clear how we think about autonomous airplanes is we're not imagining that every aircraft could be autonomous tomorrow, or that you replace pilots from significant portions in the market and all these things. We imagine developing a market that doesn't currently exist today. And that is to say, creating ultimately this market, creating new jobs in this market for, supervisors and all the rest. But we're not talking about automating large scale aircraft that are flying, again, in very highly unstructured ways between airports where lots of different things can happen. When it comes to, the very bespoke judgment cases, this is actually where I think automation can be a tremendous additive to the safety frontier. If you think about some of those cases, every pilot has their own. I have my own example of a total electrical failure in flight. Every pilot has their example of something that went wrong and they needed to use their judgment and experience and do something that was heroic. One of the things that I think is just tremendous about automation and autonomy is we can run those scenarios in simulation, and we could do those practically instantly and benefit from the entire corpus of knowledge of every failure that has existed in the past, may exist in the future, and even scenarios where it's hard to conceive of something like this existing, but we can test it in simulation. And once we do that, we could actually codify that expertise into the aircraft and again, fly it in a very limited and controlled way. So I feel extremely comfortable about these aircraft being able to meet a bar that's similar to today's air transportation system. And in fact, bring that level of safety to a segment of the market, which in this case doesn't exist, but in the case of small aircraft or helicopters are at dramatically lower levels of safety than what we're talking about here.
Brian, what lessons are you taking from the initial rollout of self-driving cars that we're seeing popping up in certain parts of the country?
Oh, I love that question. I actually just took my first self-driving car in a cruise in San Francisco, actually. I think what Kyle Vogt and the team at Cruise have done is tremendous. If you look at just, as an analogy, what Cruise is doing is they've gone relatively deep in San Francisco in terms of actually rolling out the service in a very operationally controlled way. They didn't say we're going to drive from San Francisco to New York on day one. What they said was, we're going to take this area of San Francisco. It'll be nighttime only. It'll be all these other operational restrictions. But I one day went to downtown San Francisco and I pulled out my cell phone and I requested a car, and a car drove to me without a safety driver. It was just an empty car. I got in the back. I drove through very complicated streets in San Francisco. It was incredibly safe. And I arrived at my destination, and it was just magical in how boring it was in some kind of, if that makes sense. And now, what you see the team at Cruise doing is expanding into other cities and ultimately kind of broadening the operational use cases of that system. Now, I don't want to stretch the analogy too far, because I actually think the autonomous driving problem is quite a bit harder in some ways than what we're doing here. But I do think that that's an important analogy, which is to say, automated and autonomous, aircraft and cars don't have to do everything on day one, and in fact, might not ever need to do everything. We might have driverless cars and cars with drivers in them for as far as the eye can see. And that's my opinion in aviation too, is I think we'll have automated aircraft in kind of the low end of the market, and also piloted aircraft, especially in the high end of the market, for as far as we can imagine. And these aircraft will have to fly together and exist together and so on. But how they start to roll out in very limited ways and then expand over time, I think that's just an incredibly important example for us.
Just a quick follow-up on the self-driving cars. I'm not sure what the right number is, but I've heard that there are many people in some remote operation center supervising each vehicle at any given time. So when you take a similar concept with the multi-vehicle supervisor and all of the infrastructure that is overseeing the operation of the Wisk aircraft, what's the impact on profitability? Is that something that you sacrifice in the near term, or is it something that is baked from day one?
This is one of the most important insights of autonomous systems, which is that people do not go away in autonomous systems. They change what they're doing. And of course, one of the most fun examples of this in uncrewed aircraft, especially in the defense space, is, everyone will tell you, uncrewed aircraft are anything but uncrewed, because they have people on the ground, they have people in the ground station, they have people tending to them when they get where they're going, and all the rest. And so certainly we will have, our intention is to have one supervisor that oversees many aircraft, and typically in a sum to many case, because you would want some redundancy in the number of supervisors and so on. But that's not where the people stop. So obviously you have to think about, at a vertiport location, what are the roles and responsibilities of the people at the origin and destination, because there will be people at the origin and destination to provide pre-flight functions, to walk around the aircraft, to ensure the area is clear, to receive passengers, to get passengers on board, all the rest. That is actually why thinking about this from a service level and doing the systems engineering breakdown of every function that needs to happen and how it happens in either an automated way or with a complementary human who's doing a different service, that's really important. Because unless you think that holistically, you can never close an operational case or a safety case on this. Now, to get to your point about profitability, and this is an extremely important point, which maybe gets back to your first question, which is, what do very few people in the industry agree with you on? One of the things that most people don't appreciate is they imagine that the value of autonomy is, quote unquote, eliminating pilot costs. And that's not true. The value of autonomy is actually enabling a very flexible transportation network. It is having an asset, an airplane, that is decoupled from needing to be at the same point in time as the cargo that it's carrying and being at the same point in time as an airworthy pilot that can fly it. The most extreme example of this that I can give is in the small feeder aircraft market, where you have a market that really depends on service level guarantees, getting cargo to specific point in time with an absolute guarantee that the aircraft is going to leave at a certain time. Well, you end up, because the airworthy pilot needs to be at the same place as the airplane, you end up with stranded assets for some period of time. You end up with airplanes and pilots kind of sitting around to wait to meet that guarantee in a network that is somewhat inflexible. So if you could decouple those two things and you could move the aircraft around in a network, you deliver tremendous amounts of value. It's not about eliminating quote unquote pilot costs. It's about making a very flexible asset for a very flexible transportation network.
This is a really interesting piece of insight, Brian. I would also maybe extend that to somewhat of a misconception that we're hearing from folks who are thinking about autonomous operations as a way to increase the safety of the system by virtue of eliminating the human in the loop, which I also think is a little misguided because, to your point, it's not about removing people. You're just moving where the human error will reside. And you will also introduce other risk vectors in the process of moving the pilot from the cockpit. What are your thoughts on the safety case of arguing in favor of autonomy?
Yeah, I also agree with exactly what you just said about the misconception there. The simple way that I think about it is safety is both the challenge and the opportunity for autonomy. And what I mean by that is, on the first point, the challenge point, pilots are a critical element of enabling the safe system that we enjoy today in the commercial, aircraft space. It is one of the safest things that we can do today, which is, again, why I go back to, I think the air transportation system is just full of modern miracles. It is so safe. It's hard to even conceive of the statistics for how safe the modern commercial aircraft system is, air transportation system is. And that is in large part because pilots are actually closing that safety case in many ways. So the challenge for automation is to prove, and again, in a very limited initially operational way, that automation can be as safe as the system that we enjoy today. So that's the challenge. The opportunity is to continue to push the safety frontier via our ability to automate many of the interactions with the system that may cause incidents or potential accidents today. And we can go back through history and take every potential incident and accident that was there and codify that in rules. We can imagine, we could simulate tremendous amounts of new scenarios that may happen. The ability for us to, again, in a very limited operational way at the low end of the market, to be able to write those rules into a system and to be able to push the safety frontier is incredible. That's something that I'm really excited about. So I agree with you, and I think that if you think about it as both the challenge and the opportunity, it opens up a new way of thinking that is not so adversarial in the way of saying, are pilots better or is automation better? Well, it depends. It depends on what very specific scenario, aircraft, et cetera, that we're talking about. And in this very operationally restricted low end of the market, I think we can achieve the challenge of making these systems as safe. And in fact, I think we can push the safety frontier in the low end of this market to deliver air transportation levels of safety in a part of the system that does not enjoy that today.
What is the required scale of operations at which point the added overhead of technology investment, equipage, all of the systems that are supporting the operation, all of the remote personnel involved, and all of the rigidity in some of the initial operations, at which all of that tips into positive gross margin territory?
It's tough to answer that very specifically without getting into a lot of details. I guess I would say, I'm trying to figure out how to parse this to make it most useful. I guess I would say is we look very deeply at the unit cost. So it's very tempting to look at, what's the total addressable market and what percentage of that do I think I could achieve, and et cetera, et cetera. We look at this from the other side, which is, we're not looking at this in a typical, venture capital funded way where you might take that top down view. We're looking at this from the bottoms up view, which is exactly where you're going. What are the required number of personnel? What's the unit cost to deliver a single flight or to deliver a day of networked operations, which is how I like to think about this. And I have been surprised that the scale of the network that's required in order to deliver something that has unit positive economics is actually not as large as I thought that it would be. And I think that that actually comes from the ability to increase the utilization of the assets, to be able to reposition assets, which is actually something that's not talked a lot about in these particular networks. Is there's a pattern of life that that people want to be in one place at one time and another place another time, and so you'd love to be able to efficiently reposition and all the rest. And you add up all these things, and it turns out that you don't need that many nodes, and you don't need that big of a network in order to achieve something that looks positive on a unit cost basis.
This break-even point for a particular aircraft, is that tens of flights per day, or any ballpark figure that you could perhaps share with us?
I'll say I don't know, which I'm happy to admit. What is that specific number? But we intend to achieve very high utilization on these aircraft. I don't know for a specific airplane on a specific flight, what's the break-even number of flights per day. I typically look at this from a network standpoint.
I see. Let me go back to one of your opening comments where you said that the certification pathway to commercialize this level of autonomous operation exists today. Can you elaborate on this a little bit?
Like almost everyone in this domain, we have a type certification program that is working through the Part 21 process, the 2117B process that I'm sure listeners of this podcast would be very familiar. And so from a type certification standpoint, we view what we're doing, especially because we have incredibly high levels of redundancy and incredibly high levels of design assurance in many of the other underlying systems. We view that type certification process as rigorous, as difficult, but as achievable, in the same way that others that are very advanced in this domain are, on their road to achieving type certification. Now, the important thing for everyone to understand is, even if you achieve type certification and a production certificate for an autonomous aircraft, it doesn't mean that you could fly it. So you could have a type certified aircraft that you are not operationally approved to fly. So that's why the second element of the three-part stool that I mentioned earlier is so important, because we need to achieve operational approval to fly that aircraft in the very specific way in which we want to fly it. And that, in today's regulatory environment, will require waivers and exemptions for certain of the rules. And what we have done is an extremely comprehensive assessment of the entire rule set, Part 135, even 61, 91, et cetera. We've lined up every single requirement and looked at every single way that we would either fully comply, or it's not applicable, or partially comply with an alternative means of compliance, et cetera. And so we'll work those waivers and exemptions in today's model. Ideally, there would be a rule set, of course. And so there are industry bodies that are talking about how to get there ultimately. But right now, what's available to us are those waivers and exemptions. And what we think is that when we very operationally restrict the aircraft, that this is actually a very achievable problem.
What are the regulators mostly concerned about at this stage of your conversations with them?
Well, I guess I would say the comprehensiveness with which we have assessed this problem has helped. And not to turn the question around, because I'm trying to get to what are people most concerned about, is it's very methodical. It's not that people walk into the room and say, hey, tell me about detect and avoid. It starts with a extremely rigorous concept of operations. It starts with all the models for, at the service level, how you break down the functions, how do you break down the functions for the aircraft and the system, and then just kind of doing, standard line by line, sober assessment of how ultimately you get to an equivalent level of safety for the deviations that you're asking for. And so, it's not as, it's more clinical, I think, than one might imagine.
And is the equivalent level of safety, is that a pretty well understood concept when we talk about replacing the functions that humans do today?
Yes and no. I mean, everyone in this domain, I think, has stories of, of course, to bring it back to detect and avoid as an example, everyone has stories of, if you're a pilot, you try to look out the window, you can't see the aircraft, it's very difficult. And we can go up with automated systems and see the aircraft dramatically faster than a human could, and with way higher performance than a human could, and all the rest. And so you would say, well, that seems to me like an equivalent level of safety or better. But that is not actually yet codified in the rules, somewhat famously. And so that's why I would say kind of yes and no is when you get into a sober assessment of the technical details, you can typically point to it and say, this is better than that. But how that ultimately turns into a rule set and eventually, waivers, exemptions, et cetera, that is still the domain of very high touch activity.
Hey, Brian, are you looking for additional investment? Are you looking for more money?
We announced a funding round a couple of years ago that we had raised $450 million from Boeing. We are not actually actively raising money. We're not actively soliciting new investors. We are in an extremely comfortable place with our existing investors, and we have the resources that we need ultimately to we think, to get through our certification program. So we're very opportunistic on that front, which is to say, we work with partners in a way where it's beneficial for us to learn together, but we don't show up and say, hey, we're raising new funds and we'd like you to be part of this venture.
So give us a peek into a board meeting, Brian, and how would it be different, let's say, from a public company board meeting? Is the overall theme, let's get this done right, no matter how long it takes, because the opportunity is enormous? And/or how much of the board meeting is, when are we going to get a return on the investment? We've made huge investments and we want a return sooner than later. Because my sense is, from your very articulate, crafted responses to the questions, it sounds like you're doing it right. It also sounds like the path to autonomous flight with these very strict pathways is sooner than most people think. But there's also a piece of me that says cash profitability is not the highest priority on their mind. And as a result, you're not feeling the pressure to get a return as much as you would otherwise hear in a public company. Help me out with that.
We have the tremendous benefit of a strategic investor, Boeing, who understands exactly how long it takes to do these types of ventures and what it really means to try to take the next transformational step in aviation. So to answer your question somewhat specifically, I guess, about board meetings, not to say here are the minutes from the last board meeting, but to give you a sense, we always talk about doing this right. We always talk about taking the long view. We are not rushing. We'll do, the phrase slow down the speed up. In our domain, that means doing tremendous amounts of the things that aren't always exciting, like systems engineering and model-based systems engineering, to build this incredible foundation that will be the basis of proving ultimately that this aircraft is worthy of carrying the first commercial passenger for hire. So it's all about the long view. It's all about being patient, doing the right work. The aircraft will fly when it's safe. It will be certified when regulators say so. And now we have a viewpoint on when that is, and we have a viewpoint on the economics, but every capitalization strategy that every company takes has its pros and cons. And the tremendous pro that we have is the ability to think strategically, think long-term, and do the right thing. And that's because of the benefit of Boeing.
That's terrific. Now, Boeing caught some heat for this investment. So what's the return on investment for Boeing here? Is it the cash that's going to be generated from Wisk, or is it the greater value it gives to greater Boeing?
Well, the world is not so black and white. I would say the way that we like to think about it, from our perspective, not speaking for Boeing now, but from our perspective, and what Boeing has said publicly themselves, is there's two interesting things here. Just to do a little bit of systems engineering on your question. The one is that we are building a tremendously interesting business. This business doesn't exist today. we're building a new market, which has exciting economics and all the things that we just talked about. And so we think that we could bring sustainable flight, with low noise, closer to where people live, and give them more ways to access aviation. And so that's a really cool, interesting business. So that's point one. Point two is obviously what we're doing here is pioneering technologies that are relevant for many different use cases, both in small aircraft and potentially in large aircraft someday. And that is pushing the boundaries on safety and automation, pushing the boundaries on electric powertrains and high performance electric machines. And those are all very interesting capabilities. So, when I think about this company, I think about both enabling that business and being just maniacally product focused on our Gen 6 aircraft and how to get it through certification, which we are. But what we will create as a result of pursuing that business are innovations and capabilities which have uses that are very interesting beyond just what we're doing here with Gen 6.
Brian, with Wisk being a joint venture between Boeing and Kitty Hawk, how has the shutting down of Kitty Hawk impacted your business?
No impact on our business. So, Kitty Hawk closed their operational activities, but obviously, they're not involved in day-to-day planning, execution, et cetera. So that hasn't impacted us at all. I will say, they deserve, though, tremendous credit for being pioneers in this space and for, Larry Page and the rest of the team to achieve many of the industry's first, to achieve the first eVTOL flight, the first transition, the first piloted transition. So many of the firsts have happened in this building that I'm sitting in large part because of Kitty Hawk and its predecessors. But Kitty Hawk closing its operations doesn't have any impacts on Wisk, and in fact, Wisk is kind of off the launch pad in a sense, and I think that is a tremendous success for Kitty Hawk.
Brian, I know you don't like the term urban air mobility, as you indicated up front, but just for the sake of clarity, let me just use this and say, if UAM does not end up being an initial use case, what do you expect the Wisk aircraft to perform? What other missions? What is the backup plan? Do you have one?
Sure, and I'll give some color too on why I have an aversion to that term, I guess, which is to say, we don't call 737s national air mobility or global air mobility or some such thing. And the reason is that these are very flexible machines. If you think about a commercial aircraft, it flies everything from, depending on which aircraft it is, it flies everything from 3,000 miles to 200 miles, and from sort of inter-regional traffic to what could be intercontinental traffic. And that will be exactly the same with the electric aircraft that we are making and that others are making, which is to say, these aircraft generally can fly up to about 100 miles or so. And there are a lot of locations around the world where 100 miles is not an urban mission. In fact, 100 miles can be between two cities, or it can be between two regional areas. And ideally, you could potentially have your landing sites at existing airports. In fact, we like that. That's actually a nice controlled environment. And so I think these aircraft, I think people will be surprised at how versatile these aircraft become. And it won't necessarily be darkening the skies over, over urban environments only. And so that's kind of my aversion to that term and where I think these aircraft may go in the future.
Brian, we have to get to our closing questions in a minute. There's a part of me that says, let's say the CEOs of a lot of the big eVTOL companies are listening in, and they know that their investors are constantly asking them and saying, listen, when is autonomy coming? Because at the end of the day, you guys can't really make any money with a piloted airplane. Now, they will say that they can, but at the end of the day, autonomy is really what they need to generate real cash. Are you paving the way for them? Is the work that you're doing, will it be rather easily adopted by the other large, especially publicly traded eVTOL companies? Or is what you're doing a completely independent path? They're not going to be able to follow you very easily. Well, is your success good news for them?
Yes, I think so. And the first thing I would say is their success is also good for us, which is also why I am friends with so many of the builders around the industry. I root across the board for all of these companies to ultimately break through and start to achieve what some have viewed for a long time as impossible, and to deliver a service, even if it's initially, very limited. And so I think their success is great for us, and I'm rooting for the projects that are near the finish line to get certified in the next couple of years. I think it's going to be amazing. Now, the nuance I would provide to the answer, which I think is important for autonomy, is we went direct to autonomy on purpose with a very specific, very well-considered strategy. And in fact, many times I'll show people the airplane and then they'll pull me aside and they'll say in kind of a hushed tone with a whisper voice, they'll say, "Hey, that's really cool, but can you show me where on the airplane a pilot could actually plug in and control it from on board?" And I say, that doesn't exist. There is no way to control the airplane from on board the airplane. And so people, I think, still think that we may be, hedging or something, and we are not. We are all in. We will either succeed or fail on the basis of our ability to get to market and to certify this airplane, and we're excited by that. That's the driving force in this mission. Now, from the ability for others in the industry who have pilots on board or have those considerations on board to then achieve an uncrewed operation in a certified sense, I actually think can be difficult. I don't think it's impossible, but I think it can be difficult. And to give you kind of a very simple, not exact analogy why, is imagine you were to change the propulsion system on your aircraft. You would have to go through a tremendous amount of reallocating functions on the aircraft and doing all sorts of stuff. And it may be very difficult. It may be an entirely new type certification program. This is kind of the same with trying to take functions away from a pilot and allocate them either to the aircraft or to some offboard system. If it wasn't considered up front and now it requires a wholesale architecture change or some design assurance change in a substantial way or whatever it might be, that could be a huge hill to climb. So what we've said is, yes, it's more risky to go direct to autonomy. We understand that. We will succeed or fail on our basis, on our ability to achieve that milestone. But we think that by planning for it up front, we will be able to design a system that actually can achieve it and can achieve it in the near term. And that will put us in a position to ultimately to scale and to do very interesting things in this market.
Putting aside the eVTOL autonomous flight technology and talking about the future of aviation broadly for just a second, what are some of the key insights from your prior work at Boeing and Aurora? What are some of the most exciting technologies that you have come into contact that you believe will shape the future of aviation in a significant way?
Yeah, so automation obviously, is one of them. And I think automation will appear in two ways. It will have fully uncrewed aircraft, autonomous aircraft operating in small airplane markets like the one that we're talking about here and potentially others. And then what I'm really passionate about is how we take the innovations in those fully, uncrewed autonomous aircraft and manifest them as safety enhancements in piloted aircraft in large commercial systems. So an example would be, we are, I think, developing some tremendous innovations in the multi-vehicle supervisor station, the human factors for that. Well, I would love to be able to manifest those as safety enhancements in flight decks of piloted aircraft systems in the future. So that's just kind of one example. I think the sustainability thread is one of the most important things. We haven't talked about it much on this podcast, but it's one of the most important factors driving our industry today and in the future. It's very obvious to me that electrification will play a role. It's very obvious to me that that sustainable fuels have to play a massive role in ultimately decarbonizing aviation. I think there's just going to be a tremendous amount of technologies that come along, things like fuel cells and high power electric machines that are going to allow us to start to reconceive of airplanes in more sustainable ways. And the last thing I would say, I guess, is don't sleep on efficiency. I think that the Breguet range equation is still a good guide for where the industry will go. We'll have aircraft that get more aerodynamically efficient, more structurally efficient, more efficient in a propulsion sense. And I think that we could be, for the first time in, what will be coming up on maybe nearly a century at some point, changing the architecture of large commercial airplanes to be more efficient. And that is super exciting. So I think it's just an awesome time in the industry right now.
Is it possible environmentalists or strong supporters of sustainability, which most of us are now, are a little bit bummed out that the head of sustainability for Boeing, with everything that you had in front of you, is now running a company, a great company like Wisk, but you're not having a big impact on sustainability where you are right now?
Oh, that question both hurts me and also, I think, overplays my influence, which I appreciate at the same time. So I love it. Here's what I would say is I was the chief engineer for sustainability and future mobility at Boeing. And now Jim Heilman, actually the chief scientist from the FAA, has stepped into that role, who is a tremendous leader. And I told everyone at Boeing, you got an upgrade. So I feel great about where Boeing's position will be. And Boeing, of course, still has a chief sustainability officer. And people like Mike Sennett, who I just deeply respect as someone who's delivered in the industry, as chief engineer on the 787 and is the head of product development at Boeing, are totally focused on this problem. So I appreciate that you have a viewpoint that Boeing may be worse off without me, but in that role. But it also, I don't think, accurately necessarily reflects. So now what I would say, which getting to the core of your question, is clearly the emissions in the industry are not in very small short-range markets such as this. So the statistic that I like to use is 50% of the flights are under 600 miles globally, but that's only 15%, 15% of the fuel. So 85% of the CO2 comes from flights over 600 miles. So what the industry will have to do over the next, 25 or so years between now and 2050 is replace the fuels that are used on 30,000 airplanes today, 40,000 aircraft within the next decade or so, with something that's more sustainable. So obviously there are, a number of sustainable fuels pathways. Boeing will release new efficient airplanes. It will all be good. The thing that I would just say, which goes beyond our industry, is, and this is just a passionate, I suppose, opinion of mine, is I think that on the sustainability challenge, the energy grid is the most important thing for us as a society to focus on. If we don't have massive amounts of solar and nuclear energy, we will not have the energy that's required to produce sustainable fuels, produce electricity, produce hydrogen, produce many of the things that are required in all the sectors of transportation, not just aviation. So we might get caught up a little bit in our own industry, and we need to all be making sure that we are advocating for huge amounts of solar and nuclear power to come online, or as a society, we will not achieve the climate change requirements that we have to achieve.
Quick follow-up on the statistics that you shared. Given this statistic, do you agree with how capital is being allocated to the pursuit of various technologies that will have an impact on the short end of the routes, but not really a tremendous impact on where emissions are mostly coming from?
I think so. My view is we've got to 1000x the amount of sustainable fuels. Just very simply, if we want to maintain the transportation connectivity that we have today around the globe, then we've got to 1000x that. Otherwise, you're turning airplanes off and eliminating people from connecting with each other, especially in countries that are just starting to move up the ladder and start to experience and enjoy the benefits and security and all the rest that come from connectivity. And I think that's really, really bad if we do that. So we need massive amounts of sustainable fuels. And I see that capital is starting to flow in that direction. And I think that's good. The area, which again is, I don't necessarily think everyone is focused enough, is on the grid itself and the massive amounts of solar and nuclear that are going to be required to achieve that. Now, if your comment is, should we be investing in electric aviation, or shouldn't we use those dollars somewhere else? I tend to believe that innovation and building is good, and building sustainable kind of, by default, I should say maybe zero emissions by default aircraft is good. They will push the boundaries of technology. These are useful investments. These technologies will manifest in larger scale solutions over time. And we have got to start somewhere. So if we're sitting around in 2050 and saying, boy, I wish that I had done 25 years of research and development into fuel cells and electric, but I can't now, it's too late. That is a depressing place to be. So I think more building is good. And I appreciate also that capital is now starting to flow into large scale SAF projects.
Is there anything that you prepared for that you want to share with the audience that we haven't asked?
Maybe just one thing as I sit here thinking that is worthwhile, that I'd love everyone to understand, is I get the sense that there is this belief that it's either autonomous or it's piloted. And what I mean by that is the future. And I believe that there is a world in which we will have new autonomous aircraft, which are smaller and operated in potentially restricted operational ways to make them very safe. I believe that we will have those airplanes, and we'll develop, large new markets with them and create new jobs with them and all the rest. And it will be exciting and sustainable and so on and so forth. But I also think that those aircraft will develop technologies which will manifest in safety enhancements in large piloted airplanes. And that those two systems, piloted and unpiloted, will exist for as long as we're all alive. And I think that's just really important to understand is we all think about autonomous, it's sort of really easy to go into one corner of the space on this and look back at the other and say, boy, that'll never work. But I just see a more nuanced view of this where these things coexist and in fact help one another.
And Brian, what advice would you give to the many entrepreneurs listening today who are starting and building companies?
Boy, somewhat famously, I think entrepreneurs shouldn't listen to advice. But if they were to listen to advice, I would say confident humility is something that I think about a lot. I find myself almost, this is just my own reaction, and I would encourage others maybe to think about it, is when I hear sort of a very extreme or firm opinion, I almost try to balance that in my mind. And so just to give a few examples, I think in aviation, there can be a lot of, let's say, gatekeepers. And so I try to have this reaction, which is, or maybe I should say, folks that might think this system can never change. And so I have an immediate reaction, which is maybe it can, and look at all the ways that it has changed in the past. And then if I'm faced with someone who says, I'll bring my software development capabilities or techniques from my mobile app development and so on and so forth, and we're going to go in there and do things completely differently, I find myself in the reaction of going, oh boy, there are really good reasons that things like DO 178 exist and all these rules and regulations, and those are really important. And so I guess I kind of find myself in this position of saying confident humility is really, really important. And I really look up to people that have that kind of a viewpoint on the world.
For anybody who has not known Wisk or has not known you, who are first listening to you based on this podcast, you're a thoughtful, articulate guy. And so we really appreciate you being on, Brian. This is terrific. Luke, anything else from you?
I feel like we could talk for hours, but I enjoyed this tremendously. Thank you very much for your time, Brian.
Thanks for the opportunity.
All right, that's a wrap for today. Thank you for listening to the Vertical Space Podcast. Reach out if there are topics that you would like us to discuss, and goodbye until the next episode. Unless mentioned, this podcast is in no way endorsing or promoting any person and or company mentioned, and all opinions within the podcast are solely that of the presenters. The Vertical Space makes no guarantees, warranty, or representation of any information given in this podcast. Any information given is for informational purposes and should be used at your own risk. This podcast is for general, educational, and entertainment purposes only.